All right, lesson 6, solutions of a linear equation. So the distributive property can be used to both expand and simplify expressions. We have already used the distributive property to collect like terms. For example, in the equation 2x plus 6x, we can collect the 2 and the 6 by factoring out the x, which means then we can add 2 plus 6 to make 8, and that becomes 8 times x. We've also used the distributive property to expand expressions. For example, 2 times the quantity of x plus 5 can be written as 2x plus 10. So in this lesson, we continue to use the distributive property to solve more complicated equations. Also highlighted in this lesson is a common error that you will make when students use the distributive property, which is multiplying a factor to terms that are not part of the group. For example, in the expression 3 times the quantity of x plus 1 minus 5, we should know that we do not distribute the factor 3 to the term of minus 5 because it is not in the group of x plus 1. So in your journal, let's go ahead and start with a few examples. What value of x would make the linear equation 4x plus 3 times the quantity of 4x plus 7 equal to 4 times the quantity of 7x plus 3 minus 3 true? What is the best first step and why? Well, in order to find out what the solution might be, we must use the distributive property. The left side of the equation has the following expression. Notice how, because these are a little bit long, we are going to separate these into left side and right side. So starting with the left side, 4x plus 3 times the quantity of 4x plus 7. Where will we use the distributive property on this? Well, we will need to use the distributive property to expand 3 times the quantity of 4x plus 7, and then again to collect like terms. So our work for now is just on the left side of the equation. The right side will remain unchanged for the moment. So we have 4x plus 3 times the quantity of 4x plus 7. When we distribute the 3 to the 4x and the plus 7, we end up with 4x plus 12x plus 21. Now, using the distributive property to collect like terms, we can factor out an x and add the coefficients of 4 and 12 plus 21. When we do that, we have 16x plus 21. So now we need to rewrite the right side. Again, we will use the distributive property, and the left side of the equation is going to remain unchanged. So we have 4 times the quantity of 7x plus 3 minus 3 is going to be 28x plus 12 minus 3. Notice that we did not apply the distributive property to the term of minus 3 or negative 3. Since it is not part of the group 7x plus 3, it is not going to be multiplied by the 4. Now we're going to simplify the expression into 28x plus 12 minus 3, and that becomes 28x plus 9. So now we have transformed the given equation into the following form. 16 times x plus 21 equals 28 times x plus 9. Now you can solve the equation. And after going through the steps, you should end up with x being equal to 1. So is x equal 1 really a solution to the equation of 16x plus 21 is equal to 28x plus 9? And how do you know? Well, it is because when you plug in 1 to replace the x, you get 4 times 1 plus 3 times 4 times 1 plus 7 is equal to 4 times 7 times 1 plus 3 minus 3, and so on and so forth. But you will find out that 37 is equal to 37. Since both expressions are equal to 37, then obviously x equals 1 is a solution to the equation. All right, let's take a look at example 2. What value of x would make the following linear equation true? 20 minus the quantity of 3x minus 9 minus 2 equal to the opposite of negative 11 times x plus 1. Since we have a group of terms that is preceded by a negative sign or a minus sign, we will simplify this first. The minus sign means that we need to take the opposite of each of the terms within the group, which means within the parentheses. So we're going to begin again with the left side of the equation. So 20 minus the quantity of 3x minus 9 minus 2. We need only to take the opposite of the terms within the grouping symbols. So is the term negative 2 within the grouping symbol? The answer would be no. So for that reason, we need to only find the opposite of 3x minus 9. So what is the opposite of 3x minus 9? Well, the opposite of 3x minus 9 is negative 3x plus 9. So the left side of the equation is rewritten as 20 minus the quantity of 3x minus 9 minus 2 is now 20 minus 3x plus 9 minus 2. And then simplifying the constants, we get 27 and then minus 3x. Now rewrite the right side of the equation. If we have the opposite of negative 11x plus 1, then that would become 11x minus 1. So now the transformed equation is 27 minus 3x equals 11x minus 1. We can go ahead and subtract or add 3x to both sides, because again we want to have positive x's whenever possible. So 27 equals 14x minus 1. Add 1 to both sides, becomes 28 equals 14x. And then last but not least, the answer to that would be x equals 2, because we would divide both sides by 14 and x is equal to 2. So again, checking this, plugging 2 into our equation, the right side of the equation would equal 21 and the left side would equal 21. So therefore, x equals 2 is the solution. All right, another example. So what value of x would make the following linear equation true? 1/2 times the quantity of 4x plus 6 minus 2 is equal to the opposite of 5x plus 9. So begin by transforming both sides of the equation into a simpler form. Well, this would be 1/4 times x would become 1/4 of 4 would be 2x. 1/2 of 4 would be 2x. 1/2 of 6 would be 3. Then minus 2 is equal to the opposite of 5x, which would be negative 5x, and the opposite of 9, which would be negative 9 or minus 9. So again, make sure that you do not distribute the factor 1/2 to the term of negative 2, and that you have, in general, transformed the equation correctly. So now we have the simpler equation. We can complete the solution. And it should look something similar to this, but our solution at the end should be x is equal to negative 10/7. So checking that negative 10/7 is our answer. Again, notice that we leave these answers or our fractions mostly in improper form. It just makes it easier to move back and forth between solving and checking without having to do that extra step of transferring mixed numbers back into improper form. So the right side and the left side both equal negative 13/7. So therefore, x is equal to negative 10/7 is the solution. All right, for example 4, consider the following equation. 2 times the quantity of x plus 1 is equal to 2x minus 3. So what value of x would make this equation true? Well, when you apply the distributive property and then go ahead and use our properties of equality, you end up losing your x, and the right side is not equal to the left side because 2 is not equal to negative 3. So how should we interpret this? Well, since 2 is not equal to negative 3, then the equation has no solution. Is there a value for x that would make this equation true? Go ahead and use guess and check to see if you can find one. Try a couple of different numbers before you stop. Well, did you realize that there is no such number x? Like we have shown here, some equations have no solution. Why do you think this happened? Well, we know that an equation is a statement of equality. The linear expressions on each side of the equation sign are such that they are not equal to each other, no matter what value is substituted for x. So what value of x would make the following linear equation true? 9 times the quantity of 4 minus 2x minus 3 is equal to 4 minus the quantity of 6, or 6 times the quantity of 3x minus 5. Again, transform the equation by simplifying both sides. So you would end up with 36 minus 18x minus 3 equals 4 minus 18x plus 30. Make sure you did not subtract 4 minus 6 on the right side up here. Then distribute the negative 2. This is a common error. Remember that we must first multiply, then add or subtract, just like we would do if we were simplifying expressions using the correct order of operations. So we'd have to multiply this first before we could subtract anything. So the transformed equation is now 36 minus 18x minus 3 is equal to 4 minus 18x plus 30. Now go ahead and complete the solution. And this is what you should have. 33 is equal to 34. Well, like the last problem, there is no value of x that can be substituted into the equation to make it true. So therefore this solution, or this equation, has no solution. So write at least one equation that has no solution. It does not need to be complicated, but the result should be similar to the last two problems. The result from the first equation was 2 is not equal to negative 3, and the second was that 33 is not equal to 34. Be prepared to share this in class. And when you are done, go ahead and continue the video. All right. Example 5. So far we have used the distributive property to simplify expressions when solving equations, but in some cases we can use a distributive property to make our work even simpler. So consider the following equation. 3 times x plus 15 equals a negative 6. Notice that in each term it has a common factor of 3. We will use the distributive property and what we know about properties of equality to solve this equation quickly. So what you can do is you can factor out a 3 from each of these terms. So by using distributive property, this becomes 3 times the quantity of x plus 5, and this becomes 3 times a negative 2. So notice that the expression on both sides of the equal sign have a factor of 3, and we can use our multiplication property of equality as follows. Since that is the case, these can go away because we are multiplying both sides by 3. In essence, we can take that out or divide each side by 3. So this becomes now x plus 5 equals a negative 2, which now gives us an easier equation to solve, and a solution of x is negative 7. So this isn't something that we can expect to do every time we solve an equation, but it's a good idea to keep an eye out for it. All right, time to do some exercises. You're going to do exercises 1 through 6, checking the problem every time. Keep in mind that the work shown is just one way to show the process. Your process might be different. Again, it's getting the answer that is the important part, checking your answer, making sure that is correct. And be prepared to present your examples for the problem 6 in class. All right, if you have done example 1, here is sample work, and the answer is 17/4 is the solution. For number 2, the answer to this would be -28/9. For number 3, the solution is -23/6. And again, for any of these, please make sure you write down any questions if there's something that is confusing or doesn't make sense to you. And for number 4, there is no solution. You should have ended up with 20 is not equal to -33. And for number 5, the solution is x equals 4. All right. To wrap this up, the distributive property is used to expand expressions. For example, the expression 2 times the quantity of 3x minus 10 is rewritten as 6x minus 20 after the distributive property is applied. The distributive property is used to simplify expressions. For example, the expression 7x plus 11x is rewritten as 7 plus 11 times x, and that 18x after distributive property is applied. The distributive property is applied only to terms within a group. So making sure that you don't multiply -2 by 4. Notice that the term -2 is not part of the group and therefore not multiplied by 4. And last, when an equation is transformed into an untrue sentence like 5 is not equal to 11, then we say the equation has no solution. All right, we'll see you in class.